Welcome back. Thank you for showing up for your learning. We are looking at radicals. So we want to perform radical operations and simplify where needed. Remembering how to simplify radicals can make these types of questions a lot easier to work with. So let's take a look. When we have something like 7a, where I have root 27 minus 4 root 3 plus root 243, I'm noticing that's divisible by 3, and minus 8 root 81 plus 2. Okay. First thing I would do is simplify all those radicals. So I notice that root 27 could be written as 3 times 3 times 3. That's if I do a factor tree in my head. And I see a pair of 3's, so one of those 3's jumps out. That's going to be 3 root 3 in the next line. Minus 4 root 3. I can't simplify that root 3 anymore, so that one is simplified. Plus root 243. Let's do a factor tree for root 243 because that one's going to be tricky to factor. So I'm just going to do a factor tree on a piece of random paper here. So here, 243 is divisible by 3. And that leaves me 1 plus 240. 240 is 40. 40 times 3, so that's 41. Right? 41 times 3. Check it. No, that's not right. 41 times 3 equals 123. So I'm wrong. It's 81. 81. 81 is the right factorization. So 81 times 3 gives me 243. And then that factors into 3 times 3 times 3 times 3. Just recognizing that that's 9 squared. So there's my pairs there and there. So I can write this as 81 times 3, root 81 times 3. And then, so this one just comes down. That one's simplified, but this one is plus 9 times root 3, because that 81 can pop a 9 out. And then minus 8 times root 81. Well, that's root 81 is just 9 plus 2. Okay, so that's negative 8 times 9. That's negative 72 plus 2. And now I have something I can simplify. I can collect all of my root 3's. So 3 root 3 minus 4 root 3, that's negative root 3, plus 9 root 3, that's 8. 8 root 3. Because I have 3 minus 4 plus 9 gives me 8. And what are they? They're root 3's. And then negative 72 plus 2, so that would be negative 7. And that would be final answer. Okay? And that's simplified as it can be. There's nothing more I can do that to make it simplified, but still give an exact answer. Okay, next question. Negative 3 root 3 multiplied by root 3 plus 5 root 2. So write it out. And this one is going to use the distributive property. So negative 3 root 3 multiplied by root 3 plus 5 root 2. Now I distribute this in here and here. So let's do that. Let's write it out in 2 lines. Negative 3 root 3 times root 3 plus negative 3 root 3 times 5 root 2. When I am multiplying radicals, I multiply the constant times the constant and the radical times the radical. Now I'm going to do that here, and you'll see it more clearly. So this is negative 3 times root 3 times root 3. So that's negative 3 times 3 all in the root. That's just 3. So that's equal to negative 9. Negative 9, because that one simplifies. Plus negative 3 root 3 times 5 root 2. So that's negative 3 times 5 multiplied by 3 times 2 inside the radical. So that's equal to negative 9 plus, it'd be minus, because this is going to give me a negative. Negative 15 root 6, and I get the root 6 there. And that's done, final answer. Yes? Yeah. So that's done, final answer. Let's put me over here so that I do that far less. Oh, and I'm putting myself over the questions. All right. This one here, I need to use the FOIL rule. So there, 7c, I would have this bracket, root 3 plus 5 multiplied by 5 minus root 3. Okay, so now let's do that. This is going to be root 3 times 5. So I'm going to do this one and this one here. Root 3 times 5 is 5 root 3 minus 3, because this is root 3 times root 3. And root 3 times root 3 gives me root 9. Root 9 is just negative 3. Okay? Now let's do these ones. That's plus 25. And then 5 times negative root 3 is negative 5 root 3. Okay? So this one, 5 root 3 minus 5 root 3 is 0. And negative 3 plus 25 is 22. That one's done, final answer. This cancels that, makes 0. This goes into that, makes 22. So that's my final answer there for 7C. And then 7D, 5 root 2. 5 root 2 multiplied by 11 plus 2 root 2. Minus 4 multiplied by 8 plus 3 root 2. So expand this in. This would be 55 root 2 plus 5 times 2 is 10, and root 2 times root 2 is 2, so that's plus 20. Minus 4 times 8 is minus 32, and minus 4 times 3 root 2 gives me negative 12 root 2. Okay, now I collect my like terms, or my like radicals. So 55 root 2 and negative 12 root 2 I collect. And that would give me 43 root 2. And then 20 minus 32 gives me minus 12. And that's done, final answer. So that's dealing with these radicals. Now let's take a look at some applications of radicals to areas. So if I have something like a side length root 2 and another side length of this rectangle, which is 5 root 3 minus root 2. 5 root 3 minus root 2. Okay. Now to find the area, I use my area formula of length times width. So that's root 2 multiplied by 5 root 3 minus root 2. Multiply that in. This is equal to 5 root 6 minus 2. That's an area for that rectangle. Sure. Yeah, I'll go back to some of these examples, or maybe I'll create a new example for you. Okay. One more example that we'll take a look at is here, looking at a circle, a semicircle with a 3 root 3 radius. So the area of a circle is equal to pi r squared. The area, therefore, of a half circle would be pi radius squared divided by 2, because I just have half of the size here, so it's half of the area. Okay. Now, what's the radius? 3 root 3. So let's put that in. The area of a semicircle for a radius 3 root 3 is equal to pi multiplied by 3 root 3 squared all over 2. So now, and here I'll show you where the numbers are coming from when I square this radical. Okay? When I see a square, I will definitely imagine that square as a repeated multiplication. So I'm going to expand that out. This is pi multiplied by 3 root 3 times 3 root 3, all divided by 2. When I multiply a mixed radical like this by a mixed radical, multiply the coefficient by the coefficient, multiply the radical by the radical. All right, so this will give me pi 3 times 3. That's this 3 and that 3 multiplying, the two coefficients, multiplied by 3 times 3, all inside the radical. That's that times that. All divided by 2. This is 9. This is 3. 3 times 3 root 3. This is the root 9. So root 9 is 3. So this is 3 times 3 times 3. This is equal to pi times 27, all divided by 2. And that's done, final answer. That's really simplified. Although I never would write it that way, I would always write my pi after. So I would write it this way. This is equal to 27 over 2 pi.
see like the final answer, or do you
Yep.
have to like put the pi in the extent?
If you evaluate for pi, like you put in your 3.14, you've left the realm of exact answers and you've entered the realm of approximations. So this one said, find a simplified expression for the area of each shape. This is a simplified expression for the area of that shape. And in fact, it's an exact representation of the area of that. If I put in a decimal for a radical, or I put in a decimal for pi, then I've already made that an approximation. So that's the radicals chapter. I'm going to go over a few more examples by popular demand, but that should show you how to get through those questions in the textbook.